Okay. All right, so without having to look at a graph, if I want the limit of something, I know that the limit is going to be its intended y value from last time, right? So without even having to look at a graph, I can just plug in the number. So if I want the limit as x approaches 3 for the graph of y equals 4x, I can just plug in 3. It's as easy as that. So the limit would be 12. Okay? So this is called direct substitution. All right? So for this one, the limit as x approaches 1 of e to the x. You just plug 1 in for that x, so you get e to the first, or just e. All right, so pretty easy. Plug in 0 right here. That's square root of 3. Just leave it like that. Here, plug in 2 for x, and you get 1/4. Okay? So as long as that works, that's easy. That's always the first thing you try. When it says find the limit as x approaches something and they give you an equation, plug it in, okay? That's the easiest way to do it, but we're gonna come to some in a little while that don't work that way, all right? So down here, I want you to do those 3 real quick. So you're just plugging in the number, so y'all can go ahead and do that on your own. So your answer is gonna be a number. All right, so what y'all get for number 1? You plug in 5 right there, what do you get? Somebody talk. Negative 15. So again, direct substitution is as easy as plugging it in. All right, if you plug in negative 3 right here, don't forget when you square negative 3, it turns to positive 9, okay? So that would have ended up 18 minus 12 plus 1. Did y'all get 7? And this one, if you plug in plug in 3 right here, you end up with 9 over negative 3, which is negative 3, okay? So if I give you a whole bunch of limit problems, don't forget to try this first, because I'm about to teach you a whole bunch of new stuff that you might have to do. This is the easiest thing. If this works, you go with this, okay? All right, so down here, this is where we start talking about the ones where it doesn't work, okay? We're gonna talk about these 3 methods right here, okay? Sometimes you have to factor. Sometimes you have to rationalize the numerator. That's something new. And then sometimes you have to get a common denominator, okay? So we're gonna talk about these 3 ways today. All right, so this is just an example. If I was to try to plug in, that's a negative 1 right there. If I was to try to plug negative 1 into this equation the way it's given, right? What's gonna happen on the bottom? If I plug negative 1 in right here, do you see how you get 0 on the bottom? You can't have 0 on the bottom of a fraction, right? 0 on the top is okay, but you can't have 0 on the bottom. You also can't have 0 on the top and the bottom, okay? If 0's on the bottom at all, then you can't do it that way, all right? So what you can try to do is factor. So the first thing you try, whenever you have a fraction and you get 0 on the bottom, the first thing you try to do is see if it'll factor. See how the top is x squared minus 1? That factors, right? So we're going to change this to x plus 1, x minus 1 over x plus 1. So what happens? You see how the numerator and denominator, one of them cancels out? So I'm left with only this now. So can I plug in negative 1 now? What happens if I plug negative 1 into this? Negative 2. Okay, so my answer to this problem is negative 2, whereas it originally looked like it was going to have a 0 on the bottom. So if you plug it in and you get 0 on the bottom, you can't stop there. You have to then factor it and try to get to an actual answer, okay? Now, the other way we could look at this one, what does it mean if we try to graph something like this? And we're going to spend a whole class on remembering how to graph these. Y'all remember radii from last year? Okay, we're going to spend a whole class coming up on how to graph with radii again, because that kind of helps with these. But just to show you real quick, do y'all remember what happens in Rady if you cancel something out? What does it do to a graph if you cancel it out? There was something specific. It's a hole, good. So that means on this graph, you have a hole at -1. Whatever thing you canceled out, that's where the hole is. So if it's x plus 1, there's a hole at -1, and then you plug -1 back into the equation, and that gives you the y value of the hole. So over here on the graph, -1, -2, there's a hole in the graph. We did this during the beginning, I think, of staying home right after spring break, right? So kind of depending on how much of this you learned at home, it's kind of gonna tell you how easy it's gonna be whenever we start doing the day on this stuff. Okay, but the good news is I'm gonna take the whole day and we're gonna practice it all over again. Okay, I'm not gonna expect you to remember all of this graphing. Okay, we'll start over. All right. Then you graph whatever's left over. That's just y equals x minus 1. That's what we're left with. That's just a line. Y equals x minus 1 looks like this. So do you see how it kind of goes through where the hole is? So we're doing the same problem algebraically, and then we're doing the same problem with the graph. If I gave you this problem right here, and I just asked you the question, what's the limit as x approaches -1 of this graph? What's happening? Remember last class? We have to check both sides, right? As we go towards -1 from the left and -1 from the right, where were we headed? -2. So we get the same answer here and here. So you wouldn't have to do that both ways. But if you didn't factor it, you couldn't do it this way. Okay? Any questions on those? Like I said, we'll review graphing a lot more, okay? But for today, we're just going to mainly focus on if you have to factor and cancel, then you can plug it in. All right. All right, so if you see a problem like this, and y'all tell me if my notes don't match your class kick, because I may have jumped around when I was making the class kick a little bit, so just let me know. Okay, so if I plug in a half, first thing I would do is plug it into the denominator, okay? Because if the denominator turns out to be 0, we've got to do something else anyway. So you might as well not waste time plugging it into the top, okay? So if I plug in 1/2 right here, am I going to get a 0 in the bottom? Yes. That means we can't just do that. We've got to go through and we have to factor. All right? So however you factor the top, I want you to practice that right now. So if you factor by grouping, which is probably what most of you do, I want you to go ahead and get that factored. Some of you may start by making your x and you're like, okay, it multiplies to make -6, adds to make 5. Whatever you have to do to get that factored, I want you to do right now. Hopefully as you're factoring, you're getting to this right here. When we finish notes, if this was a struggle for you to get factored, let me know and I'll help you. Same thing at home. If you need some more practice on factoring, let me know because you're going to have to be able to factor. Okay, so if you have questions or you need to have an example of this again, let me know and we'll go through it. All right, is everybody ready to move on? Once we get it factored, we have this. Do y'all see something we can cancel? We can cancel that out. So now that I'm left with just x plus 3, I can plug in 1/2 right here. 1/2 plus 3, you can just write as 3.5. So if I would have gone through all the trouble to graph that, which would have been difficult to graph, this would have been the limit as we go towards 1/2. Okay. All right. This next example, can I plug in 0 and it work? Can't do it. If I plug in 0 to the bottom, I get 0 on the bottom. Doesn't work. So I've got to come up with something else to do. Can I factor that? Y'all know how to factor that? No. So the next thing that was on our list of things to try, if you see a square root in it, y'all have heard of rationalize, right? Rationalize the what? What do we normally rationalize? The denominator. We can't rationalize the denominator. It's already an x. In these problems like this, we rationalize the numerator. Okay? It works exactly like rationalizing the denominator. It's just we're starting with the numerator to pick our what we're going to multiply by. So I hope you'll have room on there. So what you're going to do, whenever we rationalize the denominator and we have something complex like this, so y'all remember what we multiply by? It's similar to this. Not the reciprocal, but I think you're on the right track. It's called the conjugate. Y'all remember hearing that word ever before? Some of y'all yes, some of y'all no. Okay, so the conjugate, you take whatever's over here and you switch the sign in the middle. So if that's a minus right here, we're going to put a plus 1. So anytime you see a square root in the problem and you can't plug in 0 because you get a 0 on the bottom, you're going to multiply the top and the bottom by what's called the conjugate of the numerator. All you do is multiply by the numerator with the sign switched. All right, the reason that you're allowed to do this, if you have a fraction with the same top and bottom, what does that really equal? 1. So you're allowed to multiply by this, because we're just taking this and multiplying it by 1. But what's going to happen when we multiply this out, I'm going to write it down here just to have room. When you multiply square root of x plus 1 times square root of x plus 1, I've got to FOIL it. So I'm going to do this times this. What is square root of something times the square root of something equal? Whatever was inside, right? So this times this is just going to be now x plus 1. We've gotten rid of that square root. Then the next step is this one times this one, which is a positive 1 times that. Then we go to inside, which is negative 1 times that. What happens whenever you have a plus and a minus? A plus and a minus of the exact same thing. What's going to happen? They're going to cancel, right? So whenever you have a positive something and a negative something that are exactly the same, they cancel. That's why we multiplied by the conjugate. That's always going to make those two cancel, okay? And then a negative 1 times a positive 1 is a negative 1. So rationalizing the numerator makes this thing right here that was kind of complicated turn into something a lot simpler. That's the goal, okay? So this is going to be an important concept you got to get. So before I go on, do y'all understand how I chose what to multiply by? And then do you understand how I went from here to here? This is the top. Basically, I FOILed, but the O and the I, the outer and the inner, are always going to cancel, okay? So you really do this times this, which gets rid of the square root, and the back times the back goes right there. Then on the bottom, don't even distribute it. Just write it down as is. So it's x times that. Because what you're going to do now, you see how the 1s are going to cancel? What's left on the top? X. Now that you only have an x on the top, you can cancel that x with that x. So rationalizing the numerator helps you get rid of a whole bunch of extra stuff in the problem. So now we're to this right here. 1 over root x plus 1 plus 1. And remember, this is still our problem. What are we supposed to do? We're trying to get this into a form where we can actually plug 0 in. Can I plug in 0 now and not get a 0 on the bottom? That's the point. I know it's a lot of work to get to that point. It won't take as long as it just did because I talked through the whole thing. But you have to rationalize it, get it down to something simpler, then you can plug in 0. So I would end up with 1 over the square root of 2. No. Square root of 1 is 1 plus 1 is 2. So after all of that work, the answer is 1/2. But you can't get to 1/2 by plugging in 0 right here. Okay, so we'll have more of these to practice, but this was called rationalizing the numerator. So always try to plug it in first. That's the easiest thing. If that doesn't work, you check to see if it's factorable. If that doesn't work and it has a root in it, you've got to do this, okay? And then we have the third type that we're about to do, which is complex fractions. So these are kind of easy to tell apart. Does that look like something you could factor? No. Does it have a square root in it? No. That means that you can't do either of those other two things. And what you have to do is get a common denominator. Okay? So whenever you see complex fractions, that's a pretty complicated fraction, wouldn't you say? Yeah. So when you see something that looks like this, that's when you need to get a common denominator. But don't forget, if you can plug whatever's right here in right here and not get a 0 on the bottom, you want to do that. Because sometimes I'll give you a problem that looks just like this, and I'll say, what about x approaches 1? And some people will still go through this whole complicated process we're about to do when I was asking the limit as x approaches 1, not 0. Okay, so always check to make sure you can't plug it in. All right, but this one, we can't put a 0 on the bottom right here, right? So what you have to do, I always start, we're going to worry about the top first. So draw a fraction bar, okay? And I don't know how much y'all remember about getting common denominators with fractions and stuff like that, but we're not worried about the x on the bottom. We're worried about these two fractions. The common denominator between this and this is just going to be the two things multiplied together. 2 and 2 plus x. I just would rather have the 2 in the front, but it doesn't matter. So you have to take both denominators. The 2, y'all can see, the 2 and the 2 plus x is the denominator. Then what you do, if I need a common denominator, I have to multiply that numerator right there by whatever's in our denominator that wasn't underneath it. So what was not underneath 1 right now? The 2. So you take this one's numerator times whatever wasn't under it to begin with, which is 2. Then you take the next numerator, which is a 1. It didn't have 2 plus x under it. This is the fast way to get a common denominator. Okay? So these two multiply together. Just write them down. Don't FOIL it out or distribute it out. Write it down. This times what's under that one minus this times what's under that one. Okay? Are y'all okay on those steps right there? All right. Once we get to here, don't forget, we're still all over x. So don't forget, this x hasn't just disappeared. It's still under there. So what you want to do next is simplify this top part as much as you can. Okay? We still have an x on the bottom. So that's going to be 2 minus x. This step right here, if this is ever a subtraction in the middle, you have to distribute that negative. That's where people mess these up usually. I told y'all, calculus is a lot of algebra skills, okay? And not making mistakes. Leave the bottom. You don't have to FOIL that out. Okay, if you did or distributed out, it's okay, but you don't have to. All right, so then our top part, do you see how those cancel? So now we're left with negative x over 2 times 2 plus x, still all over x. How do you divide fractions? Multiply by what? So think about this. If this is an x on the bottom, isn't it really x over 1? What's the reciprocal of x over 1? 1 over x. So now I can cross out those two x's. And I know y'all probably barely have room for this. So then we have negative 1 on top, and we have 2 times 2 plus x on the bottom. And our problem was the limit as x approaches 0. If you plug in 0 right now, is the bottom still going to equal 0? Or are you going to get a number? If I plug in 0 right here, I have 2 times 2 plus 0, or 4. So what this does, it keeps you from having to try to graph something like that. Because yes, this is a lot of work, but it's way easier than graphing that to figure out the limit. Okay? And the thing about it is, pretty much every time you see a problem like this, you're going to do these exact same steps. Okay, you're always getting a common denominator. You do the exact same process. So once you do a couple of them, you'll kind of see how the steps go. But if you forget a negative, or you don't distribute correctly, or anything like that, you're going to mess the whole thing up. So you have to be really focused in and paying attention. I would suggest probably if you're ever doing these and you're trying to do it on your computer screen, this is the kind I probably would try to write on paper, just because that's a lot of stuff to try to keep up with, like writing on a screen. So I just think it would be better on paper. And it's going to take up a lot of paper too. So, all right. Can I move this one out of the way? Are y'all okay? I know that was a lot. But that's really it for today. I mean, that's the only new things we're going to learn today. So you just have to practice them over and over again. Okay. All right. So look at this one right here. All right. It says the limit as x approaches 2 of 8 over x minus 2. So what do we always try first? Plug it in. Can I plug it in? No, I get 0 on the bottom. Can I factor it? No, it's not a square root one. It's not a complicated fraction where it's got a fraction over a fraction. If nothing else happens, then that must mean that this is an asymptote and we can't actually find the limit this way, okay? There's nothing else that you can do. You just have to stop right there. And we will learn how to do those once we're gonna have to graph that, okay? So we can't do anything with that, all right? You can't fix it. All right, so we're gonna go through and do a few of these. X cubed minus 1. Do y'all remember how to factor? It's with soap. So we'll try this one. Oh, first I was supposed to check, can I plug in 1? No. If I could plug in 1, it'd be good, but I can't. So we need to factor the top. If you remember how to do it, factor with soap, go for it. If you don't, just wait, and I'm gonna go through it right now. All right, so soap says same, opposite, always positive. Same, opposite, always positive. The cube roots go here and here. And then to get this part, you take whatever you put here and you square it. You take whatever you put at the back and you square it, which is still just 1. And you get the middle by multiplying them together. 1 times x is just x. So anytime you see a sum or difference of cubes, you can factor using soap. So do y'all see what I mean about just algebra skills? We'll just have to pop up at any time and you need to be ready for it. That's kind of what's going to happen in calculus. These are things that you should be able to figure out. All right, once we get that top part factored, we have the bottom. So what is that going to allow us to do right now? Cancel. Once you've canceled out the denominator, you should be able to plug a 1 in. So we're going to plug 1 in right here. 1 plus 1 is 2, plus 1 is 3. So your limit as x approaches 1 is 3. Any questions on that one? Okay. How would you do number 2? What do y'all think? Should I factor it? Do I need to? I don't have to. I could, but I don't have to. Because am I allowed to plug in 4 right here? No 0 on the bottom? There's no bottom at all. So just plug in 4, and that'll give you your answer. So it's going to be 16 minus 16 plus 3. This one also happens to equal 3. So be happy when you see one of those that you don't have to do anything else to. Those are just the easy ones. Okay. Is this the problem y'all have next? Okay. You don't have it on class kick? What is next on your class kick? Anything else?
Well, it's just the wrong question.
Different questions? How about y'all, let's see. What is the problem on your class kick? Okay, since most of y'all are using the class kick, instead of doing this problem right here, let's do this problem. Okay, if you're using my notes, just change this problem to this problem and just write it. You should have some blank space, right? Oh, what's the limit on the class kick? Does it say? All right, so we're not doing that problem, we're doing this problem. Okay, so the limit as x approaches 2. Can I just plug it in? No. So this is one. I try to plug it in, doesn't work. Can't factor it. Don't need to rationalize. This is the fraction kind. What do you have to do in a fraction problem? Common denominator. All right. So remember, this fraction bar is the one that's for the x minus 2. We have a fraction bar on the top. The first step is to take these two and multiply them. So this times this is 4 times x plus 2. And you don't actually have to distribute. Then you multiply the numerator here by the denominator down there. I'm going to go ahead and show this just so you know what I did, but you could really just write 4. Then I have to multiply that numerator of 1 times that denominator. So it's kind of like butterfly. You remember doing butterfly? Sort of like that, but it's not equal. So this times this is the bottom, and then this times this goes here, this times this goes here. Any questions about that? Now we have to work it out. So on the top, 4 minus x minus 2 over 4 times x plus 2. And all of that is still over x minus 2. So I'm going to come down here. So I have negative x, 4 minus 2 is 2. Negative x plus 2 is on top. 4 times x plus 2 is on bottom. And y'all speak up if you don't understand where I got something. All right. Yep. I distributed this right here.
Oh, I forgot.
Yep. And now I'm simplifying that to negative x plus 2. Okay. So now, remember, you multiply by the reciprocal of the denominator, which is going to end up putting the x minus 2 on the bottom. So now we're looking for something that we can cancel out. Be careful on this. You can't cancel that x plus 2 and that x plus 2 because that's really negative x plus 2. So what you have to do is realize this. So you see how this and this are backwards of each other? If you have numbers that are opposite of each other, like 5 and negative 5, what do they equal? No, 5 divided by negative 5. That equals negative 1, right? So if you ever see something like this and something like this where both of the signs are switched, you can cancel those out and they really equal negative 1. Did y'all follow that? X plus or x minus 2, and this is basically 2 minus x. Those are opposites of each other, so they equal negative 1. So now, after all this work, I have negative 1 left on top and 4 times x plus 2 on the bottom. And this was my problem. The limit as x approaches 2. Can I plug in 2? I can now plug in 2 right here. 4 times 4 is 16. After all of that, my answer is negative 116. It's a lot of work. None of it is like super difficult. It's just a lot of steps and a lot of places you can make errors, okay? But once you learn the process, all of them are gonna have the same steps, okay? All right, so I'm gonna guess that number 4 is not in your notes either. What is y'all's? Do y'all have one with the square root in it? Okay. So we're gonna do the problem that y'all have in class kick. What is your class kick problem? Is it limit as x approaches what? Negative 3? All right, what's the equation? All right. So this should be the problem that y'all have in your notes. So we'll go with this one. Okay. First thing you always try, check to make sure it's not a number you can plug in. That saves tons of time. But unfortunately, it's a 0 on the bottom, so we can't do it that way. So we have a fraction in the top. We're going to not a fraction. We have a square root in the top, so we're going to rationalize the numerator. All right, so remember, you're going to multiply the square root of 1 minus x, and then what do you put here? Opposite sign. So whatever sign was in the middle right there, you switch it. And you always keep the top and the bottom the same. So that's what I mean when I say rationalize the numerator. So we're going to FOIL out the top. This times this, remember, is just going to be 1 minus x. This one is a positive. This one's a negative of the same thing. They're going to cancel. This times this is minus 4. Leave the bottom alone. You don't have to actually work it out, because typically what's going to happen with the bottom, we're going to be able to plug it in and it's going to end up working. Because the top of this, do you see, is going to be negative x minus 3, right? You see how that works? What do you notice about these two? Yeah, that's the same thing we just had in that last problem. This one and this one are exact opposites of each other. If you don't understand why that's happening, we could also do this. You can factor the negative out. If that makes more sense, these cancel. So this whole top part right here equals negative 1. Okay, because we're canceling it out with the bottom and calling it negative 1 over this. You have to be careful with your square root. Make sure you keep the plus 2 out behind it. After all that, can I plug in negative 3 right here now and not get a 0 on the bottom anymore? So if I plug in negative 3 right here, I get a 4. What's the square root of 4? 2. So this ends up being 2 plus 2, so negative 1/4. Is that the last part of your notes? Okay. All right, so that's examples. Your homework today is on Class Kick. Okay, so you're going to look in Class Kick, and it's Unit 2, Day 2, and it should say homework this time. Okay, so y'all work on that. Go ahead and stop the video. It's the end of the